Hi, today we're going to talk about strlen in C++, as if in strlen not as an algorithm, but as a piece of code written in a high-level language. Okay, let's go back to the strlen we have been looking at for the last few videos, right? The only difference is I added some logging here, and I also called it, actually, for a string with 43 characters in it. Right, and we can see that program returned 43, so it at least sort of works. And I printed the addresses. Right, the address of the beginning of the string is B ends with B0. The first aligned address ends with A0, and the second aligned address we're gonna load from it ends with C0. As we discussed, loading from those aligned addresses is perfectly legal from the point of view of the operating system, from the point of view of the processor. So the real strlen, it's all it cares about because it's written in assembly. However, what if we wanted to use the same tricks in a higher level language like C++? Then we have to deal with how this interacts with the language abstract machine and all that stuff. In fact, it kind of boils down to two questions. First of all, how does it interact with dynamic analysis? And second, is it undefined behavior? So basically, is a compiler allowed to turn a code into a pumpkin? Okay, let's start with dynamic analysis. I'm gonna add fsanitize address. Alright, and our program crashes. Crashes here before we do the first load. Right? Basically, yes, as a address sanitizer sees that we try to load something from an address we didn't allocate, so it will crash. This is a very common trick, right? And address sanitizers and thread sanitizers have ways to disable certain functions, certain loads and stuff. And so this is what our unsafe modifier does. So if unsafe if load, will disable sanitizers for this specific load. It's written with attributes, right? This is Clang GCC, this is MSVC version. So yeah, this is fine, and this is the intended use case for sanitizer disablement. I discussed this actually with Kostya Serebrynych, who was a team lead at Google on the sanitizers team, and he confirmed to me that this is the intended use case. However, as we know, sanitizers is not the end and all of their dynamic analysis. There's Valgrind, there's maybe some other tools that I'm not familiar with, and it would be for our library, we say, it's fine, right? We will support sanitizers, and if you use something else, then probably you will have to do the disablement on the in the usage. Like every dynamic analysis has some sort of disablement, and you will have to disable it for the functions using our library. However, if the compiler were to break your dynamic analysis, probably people would not be happy, right? So this is why I think compilers don't vectorize strlen, right? Well, strlen is actually it's an interesting example as far as learning goes, right? It's a popular function and it's one of the easiest one. However, that's not the most common function. So probably find with two boundaries is a more common one. So let's have a look at can the compiler vectorize find, right? This is GCC, this is find, right? GCC, ICC, I have here MSVC. Anyways, none of them can vectorize find. Why? Well, actually, if you think about it, it's the same problem as vectorizing strlen. Because there is nothing that tells you from this while f not equals to last, right? There's nothing tell you that L is actually anywhere reachable from f, right? And so there is never a place where you can say, yeah, okay, I have enough space to load all the 32 bytes. All it tells you, so you would have to rely on the trick with aligned addresses to vectorize this. And so if the strlen is not vectorizable, this is not vectorizable. However, if we were to write it as std_find, a std_find would guarantee that that L is reachable from f, right? In theory, on paper. Like the C++ standard says it's guaranteed. I'm not sure the compilers would go for it. Like it's definitely not vectorized now, right? And I'm not sure the compilers would go for it because, people may rely on the behavior, right? That standard find is this loop specifically. In C++20, they introduced student seek, right? Which is a special execution policy that is supposed to enable vectorization. And here, if there is a place to rely on L reachable from F specified in the standard, this would be it. Unfortunately, the only implementation that I know does something with student seek is GCC's one, and no, it doesn't do any vectorization. It could have. It's a shame. Maybe, the future versions of the compiler and the library will. Okay, so with this, let's look at the second problem, right? Is unsafe load undefined behavior? Here's my reasoning. First of all, C++ is allowed to call assembly, right? And this is why strlen, this is how strlen works. Like you call some function implemented in assembly from C++, and strlen does all the unsafe loads, and it is okay because it's written in assembly. So I'm fairly certain if I were to rewrite enough of those utilities in assembly, then my code does not contain UB. We're not doing that though, right? We are actually, if that doesn't implement those in assembly because it's a lot of work. If uses intrinsics, and I'm not sure how much C++ rules affect the intrinsics because intrinsics are not part of the C++ standard. Nevertheless, even if intrinsics are not part of the C++ standard and it's legal to load those intrinsics, we also do the whole pointer manipulations where we try to point to the position before the beginning of the array. That is not legal in C++, right? In C++, only the pointers to the beginning of the array up to past the end of the array are legal pointers, right? As far as I understand, I'm not sure I understand that correctly. And so computing that pointer might not be legal, but giving that, if I do enough effort and if I insert enough assembly in there, the code will be not UB, I think it's good enough for me, right? And with this, I think we're done with strlen. I think you should write strlen. Like, it would be a really good exercise. It will hopefully take you about a day. You can find all the presentations with all the links in the description. And after that, you will be in a really good spot, right? You will know some of the basics of strlen, of SIMD. You'll play around with it a little bit. And, for example, the job interview, I think it's a really solid answer. Like, have you done any SIMD? I wrote strlen once. Good stuff. And with this, we're done for today.